Yeah.
Yeah, what's the worst I could do to a lesson factoring? Yes, it's so good.
You have to pride in the stimulation.
Yes. Oh boy, well, okay. 11.4, roots of complex numbers. Roots of complex numbers. Roots. So roots of complex numbers. It is, roots of complex numbers. It's like finding the square root, the cube root, the fifth root. Again, like I've stated before, you won't see this probably unless you take Calculus 2, which you may or may not. This is where you run into this type of stuff with its polar and imaginary and complex numbers and things like that. So with this, on the roots of complex numbers, we don't have many problems to do. So let's just do a couple examples and then set you to task on this. So the roots of complex numbers. Now, on a complex number, right, we understand when you hear the word complex number, you should be thinking A plus BI, right? Now that is in which form? Rectangular. What is it in polar form?
A cis.
R cis
Theta.
Hey, but at least you said cis.
Oh yeah.
Yeah, R cis theta, right?
Yeah.
So those ones go together. It's a complex. This is rectangular form. This is polar form. If you were in non-complex, you'd be thinking, right, this and then this. It would be x comma y, and then polar form would be r comma theta, right? So if we are to do so an example, this is actually just an example, like the book does this one, but I'll tie in with it because we don't have too many examples to do. If we were to do the cube roots of 8i, okay, the cube roots of 8i. So 8i, is this in rectangular or polar form? Let's start with that. Rectangular form, right? If we were to graph this, right, on a diagram, where would this be? Remember, in a imaginary and complex, right? The x-axis is real or imaginary?
Real.
Okay, that's your real, and then this would be your imaginary, right? So you'd be over 0 up 8, right? So it'd be over 0 up 8. That would be the spot. And sometimes we have that arrow going out to that spot there. So the cube roots of 8i are asking what times what gives you 8i. That's what the cube root. If it was a square root, saying what times what gives you that. If it's the four roots, it would be what times what, 4 times. So with the cube roots of 8i, we can think of this as this notation, z cubed is equal to 8i. Meaning z is just a, something out there, like that would be z, right? And so you could write it as z cubed is equal to 8i. Now, if we wanted to, which we do, because with Demoivre's theorem, do you remember Demoivre's theorem? That was with r cis theta to the n. What's that equal to? Demoivre's theorem said it was
R to the n.
Cis and theta, right? Remember that? So if we were to convert this, we would, into polar formatting, we would say, okay, this would be like r cis theta to the third, if we're going to do a polar conversion. Then what's 8i in polar formatting? It's going to be something cis theta, right? So it's going to have a cis and it's going to have an angle measure. We could do a conversion, or you could just visually look at it, right? Going up to 8i. What's the angle measure to get to there? 90, right? And then what's the R value to get out to there?
8.
8. So without even doing any type of conversion, you could just go 8 cis 90. Now, if you had to do a conversion, I know that was like probably 5 days ago that we talked about conversions of this. How do you convert without just visually looking, 90 degrees up 8 cis 90. How do you convert 8I into, from rectangular into polar? Think about that. Because what if it was like 2 plus 5I? How would you convert it?
Draw a picture.
Okay, draw a picture. So, yeah, and we did that, right? We had 8I. So, the picture kind of gives it away that it's pretty easy, but it's up, right? This is up 8 and 8I technically. So, when you go to convert it, how do you find the angle measure? And maybe it'd be easier if I gave you like 2 plus 5I, to practice over 2, up 5, and here's 2 plus 5I. How do you convert that? You're looking for this value and that value, right? And this is 2 and this is 5, right?
Yeah.
And so how do you find R?
Law of sine.
No, R. Pythagorean
Oh.
theorem, right? 2 squared plus 5 squared, right? That would give you R. And then how would you find theta? Tangent of theta equals 5 over 2, right? So with 8, it's a little, you don't have that right triangle, so it's actually easiest to actually visually go through it. But you would do the same thing. You would say the R value is equal to the Pythagorean theorem, so it's 0 squared plus 8 squared, which is just going to be 8, right? And then it would be tangent of theta is equal to the angle measure, right? Which would be, what's the angle measure? It would be undefined because it's at, it'd be 8 over 0, the y value over the x value. So it's and if tangent's undefined, you have to know that that's at how many degrees? 90 or pi over 2 or something, right? So visually, it actually would be easiest just to look at it and know how to convert it. Say 90 degrees up 8 cis 90. Going in the algebraic way, you get the R value, you get this, which would be undefined, and you're like, undefined, you actually have to know when tangent is undefined, you're at 90 or all the way over at 270, right? So easiest in a sense just to do that. Now, what we know here then is this is R cubed cis 3 theta, right? If you do Demoivre's theorem on the left-hand side, and then 8 cis 90, okay? So what we have here is we can take R cubed and 8 and connect those, and then 3 theta and 90. So R cubed is equal to 8, and then 3 theta is equal to 90, right? Now, R cubed is equal to 8. What do you get out for that?
2.
That's just going to be 2, right? So R is equal to 2. Now, the issue with the 90 is that this actually can be plus, which we did this like in trig stuff, multiples of 360. Because you could actually, right, if you go here up to here, then 360 around, 360 around, 360 around, you're just going to end up in the same spot. Now this is just R is equal to 2. This one would be theta is equal to, divide this by 3, so 30 degrees plus multiples of 120 because you divide it by 3.
Oh.
Right, so we did this actually when we did some trig stuff. So what we have here is theta is going to equal 30 degrees, 150 degrees, and 270 degrees, because it's multiples of 120. So 0, 120, and 240. And the reason why we're only doing 3 of them, because there's it's the cube roots. If it was 4 roots, then we'd have 4 theta, there'd be 4 of them. So multiples of 120, this is like 0, 120, and 240. So 0 plus 30 is 30, 120 plus 30 is 150, 120 plus, 240 plus 30 is 270. So now what you have is you have your R value, which is 2, cis 30, 2 cis 150, and 2 cis 270. Right there. You could do conversion of all of those. If you went to, this would be good to practice. Convert these for me to rectangular form, 270, right? Convert those to rectangular form. So this would be good practice for converting. If these are all unit circle values, right? So they should have simplest radical form on them, because they're all unit circle values. So do a conversion for me. Okay, so we should be nearing the conversion process unless, we've forgotten how to do it, which happens. Remember 2 cis 30, again, a little visual, like you're saying, okay, I'm up 30 degrees, I'm out 2, right? Maybe let's go out there so I can make the triangle. What you're looking for is not X, but what letter, technically?
Alpha.
A and B. You're looking for X and Y, but it's an A and a B, right? And then you already know your R value. What's your R value? 2, right? So you're wondering what is B, what is A? And so you can either just do that looking for A and B using trigonometry, or you can recognize that this is, remember, 2, and then do you remember how this went? Cosine of 30 degrees plus sine of 30 degrees I, right? That's the cis part, cosine of the angle, sine of the angle, and then the I portion right there. So you could do it that way, or just think through, I'm just looking for an A and a B. If you do it this way, it's already in the AB format, right? And you would go, what's cosine of 30? Root 2 over 2, right? Times 2 is just, I said root 2 over 2, it's root what? 3 over 2 times 2, so it's just root 3 plus sine is 1/2. So root 3 plus I. Is that what you got?
Yes.
If not, you should have, okay? So now, with that, you could have also done what is the sine of 30 degrees equal to b over 2.
2 times that.
And then it's 2 times sine of 30, which you're like, oh yeah, 2 times sine of 30. It's the same thing, okay? So you get root 3 plus I, and then what did you get for this conversion? 2 times cosine of 150 plus sine of 150 I, right? And what did you get out for that? Negative root 3 plus I. Good. And then 2 cosine 270 plus sine 270i. And cosine of 270 is 0, right? And sine of 270 is negative 1. So this would have just been negative 2i. Right? Okay. Now, what we found, so we found polar, the cube roots, and then we found rectangular, and rectangular, right? So with this, okay, let's think about this, kind of try to pull it all together, what we're doing. If I said, what is the cube root of 8? If I'm just asking for the cube root of 8, hopefully all of us know, forget cis, polar, rectangular, imaginary, just say, hey, what's the cube root of 8?
2.
All of you would know that the answer is 2, right? You can only have 2. You can't have 2, you can't have negative 2, it's just 2. You can't have 1/2 times 1/2 times 1/2, you can't have 2 times 1/4 times 10, it's just 2. That's your only answer. The cube root of 8 is 2. So when we come back over here, we said, what are the cube roots of 8i? Well, we just came up with 2 cis 30, 2 cis 150, and 2 cis 270. So the question is it, and maybe you're not asking this, but when we say cube roots, we're asking what times what gives you 8i? Well, is it this times this times this that gives you 8i? Or is it asking this times itself 3 times to give you 8i? So let's do a little brainstorm here. Is that we can use this if we wanted to and say cube root plus I cubed, right? We could do that. That takes work. We could also just take this and say, hey, this one cubed, what do I get? Well, that's nice because I get what? 2 cubed is 8 cis, and then 3 times 30 is 90. Well, now if we now again, what we're looking for, the original, what were we looking for? Rectangular, which is 8i. And so if we say, well, what's 8 cis 90? You could go 8 cosine of 90 plus sine 90i, right? And what's cosine of 90? 0. What's sine of 90? 1. And so what would you end up with? 8i, right? Yeah, well, 8 times 1i, which is 8i. So you end up with 8i. And isn't that what we were looking for? 8i. So what we actually found then, in this case, is this is the cube root in and of itself. That's a cube root of 8i. This, what do you think if you multiply this by itself 3 times? 8i. 8i. What would this be? 8i. And it will work out that way. Now, the reason why you can end up with 3 different cube roots, whereas here you can only get 1 cube root, it's just 2, is because in the imaginary, in the complex plane, and you think about it like I times I can give you I squared, which would be a negative, and you can have these multiple different variations of that to end up actually at the same spot with different angle measures. So what we just found out is cube root, cube root, cube root, but they're not multiplying by each other.
Right.
This in of itself is the cube root. Yeah. This cubed, this cubed, this cubed. So you found 3 different cube roots. Does that make sense? Mm-hmm. So yeah, you found 1 cube root. Doing like that method here, but that's why we do the multiples of 360, because there's actually 3 different cube roots that we can find.
Yeah.
Okay. The book gives you the nth roots of a complex number theorem. It is somewhat complicated looking. I could put that on a test for you. It looks a little complicated, and it's in your book. This is the nth roots of a complex number. So if you had, and I'll just write it out and then try to explain it. Although I don't know if we really need to. It's not that. So it's like, whoa, what is this? It's exactly what we just did. This is z to the 1 over. I'm sorry, this is 1 over. All this is saying the cube roots of z, where z, if it's in polar form, is r, cis theta. And all we did, if you think about it, we said r cubed is equal to 8, meaning 8 to the 1/3 is what we did. And that's why it's a fractional, like 8 to the, it'd be z to the 1 over n, like z to the 1/3. And then we took 90 degrees divided by 3 because it was a cube root. 3 multiples of 360 divided by 3, so it ended up being 120, and k was 0, 1, and 2. So, I don't know. The formula is not complicated, it just follows what we did here. But let's do one more brief one. Okay, and we can kind of look at that formula. The 4 fourth roots. So 4 fourth roots of negative 16. So fourth roots of negative 16 means negative 16, right? And you want to find out what multiplied by itself 4 times gives you negative 16, okay? So in that, we can set it up like the same way that we did on the last one. If we want to, you could say, okay, negative 16, this is in rectangular form, even though we don't see the imaginary portion, right? But it's rectangular. Think about it on a graph. What would this be on a graph? Which way would I go?
Left 16.
Left 16, right? And so we're right there at 16. Okay, so we went left 16. So if you thought about that in cis format, what is that in cis format?
Negative 16. Wait, cis 180?
So it would actually be 16 cis 180, right? Because the cosine of 180 will be negative 1.
Yeah.
And that would be 16 times a negative 1, giving you the negative 16. So the r value is always positive when we do these, if you recall us talking about that. So in this case, if you recall us talking about how the r value is always positive, what we'd really be looking at here is 16 cis 180, right? Or and the book actually talks about it in terms of pi. We could do this in terms of pi. Instead of 180 degrees, what would it be? Pi, right? So you might see that in the book in terms of pi, which maybe that would be good for us to practice. But the 4 fourth roots of negative 16, so really what we're asking is, if we kind of take this and we say, okay, this is really z to the 4th is equal to negative 16. We're going to say r cis theta, right, to the 4th is equal to positive 16. But it's not just positive 16. What is it? 16 cis 180 or pi. Let's do it in pi, just in terms of pi, just so we get practice. And then this would be to the fourth. So all we did is we said, hey, the fourth roots, right? Z to the fourth thing, because you'd be taking the fourth root of negative 16. And then, so then we're going to do a conversion to polar. And what this would be is r to the fourth, right? Cis for theta is equal to, well, we're doing the fourth roots. I'm sorry, I don't know why I put 4 there. 16 cis pi, right? So in this then, we are looking at r to the fourth equals 16. For theta is equal to pi plus multiples of
360.
360, or if it's in terms of pi, 2 pi. Okay? So this is where the formula is, where it's like r to the 1 over n, and we're looking for the what roots? We're looking for the fourth roots. So that's why it's actually like, you could say 16 to the 1/4. That's what the 16 to the 1/4 would come from.
Okay.
And then cis, and then this is theta over 4, because it's the fourth roots. So it's like cis, and you would say theta, which is pi over 4 plus, now they say k times 360, but we're not going 360, we're going 2 pi, right? Divided by 4. And so, and then where k is equal to 0, 1, 2, and how many roots do we have? 4. So k in this case would be equal to 0, 1, 2, and 3, representing the 4 different multiples. So that's how the formula would work for us. And so 16 to the 1/4 is, that's a nice easy one, right? 2 cis. And then we would just do we're going to end up with 4 different answers. 2 cis, 2 cis, and 2 cis. And the first one is going to be where k is 0. So you're going to get 2 cis pi over 4. The next one is going to be pi over 4 plus 1 pi, right? Because k is 1, I'm sorry, not 1 pi, but pi over 2. It'd be easier in degrees, right? Because then you're just adding like 30 degrees plus 120 degrees. Here you have fractional work. And then this one would be pi over 4 plus pi, because the k would be 2. And then this would be pi over 4 plus, this would be 6 pi over 4. I'll just show the work. 6 pi over 4. Or we could even have said, maybe it would have been better to say, like 2 pi over 4. So that we see, and then 4 pi over 4, and then 6 pi over 4. I don't know, maybe that would have been easier. Because you're going to be adding together.
2 pies.
Oh yeah, just make it.
Oh, I don't know why there's 2 pi's there. Don't do that. Yeah. Just, you're adding 0, is 0. So I just wrote pi over 4. Then it's pi over 4 plus 1 times 2, so it's 2 pi over 4. K is 2, so it's 4 pi over 4. K is 3, it's 6 pi over 4.
Yeah.
So then this ultimately would be 2 cis 3 pi over 4. And then this one would be 2 cis 5 pi over 4. And this would be 2 cis 7 pi over 4. Okay? And then you could convert that ultimately back to rectangular form, which we know how. And if it's helpful, you could go 3 pi over 4 and turn that into degrees, because radians can be a little bit of a challenge. You could do degrees and get it into rectangular form. And ultimately, generally they end up with answers in rectangular form, since it's asking for, that's already in rectangular form. This was in rectangular form, and so your answers would be the cube roots or the fourth roots in rectangular form. So I don't know if that formula is that useful, personally. It makes sense, but I think just follow the pattern of like what we did there, but you can do the formula. Okay? I think you only have a few problems, don't you? Did you not get a sheet?
We never did.
We never did.
Never.
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 Never. Okay, well, that's gonna be